Okay, today's lecture is going to be very low tech. We're going to look first at these trichords. Now, as I mentioned before, I'm mostly going to talk about trichords, tetrachords, and a little bit of hexachords. The trichords are the ones that I think we can actually hear pretty well, and we can recognize. Tetrachords, somewhat. And then once we get bigger than that, it's hard to hear them as units. But trichords definitely, this is, similar to how tonal music works. We have triads, seventh chords, and then above that, things get a little weird. But, okay, so here we have, this is in your Hicks packet. I forget what page it is, but this page is in there. And we have these, how many did we decide there were? 12 different trichords. So the first one is the 3-1 chromatic trichord. Now you've noticed that I've included the three rotations, close spaced rotations of that same chord. There are only three, 0, 1, 2, 0, 1, 11, I guess. And then 0, 10, 11. Now, this brings us to a question we didn't talk about last time, which is, we noticed that let's look at the next one, 0, 1, 3, which is an important chord. We could call this the octatonic trichord. We'll learn about why I might call this the octatonic trichord. 0, 1, 3. You can see we're going order, we're getting bigger and bigger. This is kind of the way, and then we start going to here. It's got a certain logic to it. But anyway, the octatonic trichord. Now, look at this second little thing here. I've included this. This is the inversion of that. Okay, so instead of going 0, 1, 3, 0, 1, 2, 3, 0, 1, 3. This is upside down. 0, 1, 3, 0, 1, 2, 3, 0, 1, 3. So that's the upside down of the inverted version of it. Do you remember every set class, that's the 3, 2, or the 0, 1, 3. We could call it either one of these names. Every set class, with some exceptions, has 12 transpositions and then 12 transpositions of the inversion of the prime form for a total of 24 unique pitch class sets. Now, why is there not an inverted version of the 0, 1, 2? Well, that's an interesting question. That gets us to why there is this 12. And let's go to our pitch class set, our, fort chart, if we want to call it that. And you'll notice that some of these set classes have these numbers in parentheses. They're all factors of 12 or factors of 24. Most of them are 12, some of them are 6, 3, and even 2. Well, I'll tell you what this means. This simply means that there are only 12, instead of 24, there are only 12 unique pitch class sets in this set class. In the case of 312, there are only 4 unique pitch class sets within this set class. Now, what does that mean? It can mean two things. One, it can mean that this is what's called an inversionally symmetrical set class. And that means that it's the same upside down as right side up, so that if we invert it, it turns into another, essentially, transposition of the same set class. So the 0, 1, 2 inverts if we do it upside down, and I'll show you on the piano. 0, 1, 2. Well, if I do it upside down, 0, 1, 2. That's another, it's the same going up as it is going down. So that's called inversional symmetry. Same thing with 0, 2, 4. 0, 2, 4, 0, 2, 4. We could look at some more complex ones. Okay, how about this one? 0, 3, 6, 9. You'll recognize that as the diminished seventh chord. 0, 3, 6, 9, 0369. Okay, but the 0369 is kind of unique. Let's look at the 0369 again. Right here, 428. Oh my goodness, this only has 3 unique pitch class sets within that set class, okay? Well, the fact that it is inversionally symmetrical means that we've eliminated half of the possible pitch class sets. Well, then that should be 12, but how do we get down to 3? Well, that's because it's not only inversionally symmetrical, it's also transpositionally symmetrical. And you may already know this, but if I take my diminished 7th chord, I transpose it up by 1 semitone, I get an entirely new pitch class set, C sharp, E, G, B flat. Transpose it up by 2 semitones, new one, D, F, G sharp, B. If I transpose it by 3 semitones, this thing up by 3 semitones, same pitch class set content. I've got a C, I've got an E flat, F sharp, and A. Same as what I had here. If I go up 6 semitones, same thing again. 9 semitones. So you can see I've only got 3, there are only 3 unique diminished 7th chords or 0369s in the 12-tone equal-tempered universe. And inverting them doesn't change them. So there are only 3 pitch class sets in the 0369. Where are we? There are only 3 of them because of that, because of both inversional symmetry, it's the same upside down as right side up, and transpositional symmetry. We transpose it by 3, 6, or 9 semitones, we get the same thing. Another example, the 048, which you will recognize as the augmented triad. This one also only has 4 unique pitch class sets in it, this set class. Okay, this is another one where it's both inversionally symmetrical, 048, 048, but also, if I transpose it up by 1, I get a new one, 2, I get a new one, 3, I get a new one. If I transpose it by 4 semitones, I get the exact same pitch class content. If I transpose it by 8 semitones, I get exactly the same pitch class content. So that's what that means. So let's go back to our list of trichords. Okay, that's the octatonic trichord. I'll tell you why. It's because the octatonic scale, which is called the diminished scale in jazz, and its alternating semitones and whole tones. We'll learn about this a lot, but octatonic because it has 8 pitch classes in it. And really, this is the whole scale. So this trichord, contains the octatonic scale in microcosm. So that's why I call it the octatonic trichord. Then we've got the atonal trichord, which we talked about before, the 014, which Webern loved, but they liked, or this, the inverted version, but it has these kinds of shapes that they loved. And we associate these with, kind of like horror movies and stuff like that. Okay, then we have our major 7th trichord. Such an important part of the major 7th chord. Even the inverted part of it is the upper part of the... That sounds like that. I could walk 1,000 miles. I can't do it I'm holding this camera with one hand, with this phone. Anyway, and then this, they both form an incomplete major 7th chord, so that's why I call it that. Then we have our Viennese 4th chord. This is kind of important too. This is the second most important chord for the second Viennese school, 016. This is interesting because we've got this one, okay, that middle one right there, and then if we invert it, that chord right there, which is extremely important, not just in Viennese music, atonal music, but also in jazz. It's an important, voicing chord. If I play this and then that gives me a 13th, or if I do this one, especially if I do this one, that's the sharp 9 chord, which is also, we can think of split 3rd chord, which that's the Foxy Lady chord, if you know that Jimi Hendrix song. But anyway, this important part of it, tritone, perfect 4th, which the Second Viennese School and jazzers love so much, actually is part of this. The 3-5 of the 0-1-6. Then we get this one, 0-2. Wait a minute. Yeah, whole tone trichord. Sorry, whole tone trichord right there, which we talked about again as only having 12 unique pitch class sets because it's inversionally symmetrical. It's just 2 whole steps. Then we've got our pentatonic trichord, which kind of gives us an incomplete minor 7th, but is very reminiscent of the pentatonic scale. Either version will give us we can create a pentatonic scale with it. And then we've got our dominant 7th trichord, which is kind of like an incomplete dominant 7th in that version. But then the inverted version is this, which isn't really, well, it's not reminiscent of it. It's more like an incomplete half diminished chord. Then we have our sus trichord, which this one's super interesting. It's a little tricky because look, we take that pitch class set C, D, G. We go like this, it turns into quartal harmony, which we'll talk about later. This is the practice of stacking perfect 4ths instead of 3rds, as we do in normal triads. But then we do the next rotation, and it's a sus4, sus2, sus4 from the same 3 pitch classes. Then you'll notice there's no inversion. Again, that's because if I invert it, 0-2-7, if I go 0-2-7, I get the same set class, but it's not in, well, what's my point here? Anyway, you get this one here. It's kind of interesting. Very important shape in a lot of music. Certainly the music of any composer that uses quartal harmony, like Paul Hindemith, and then lots of jazz also, like modal jazz, like John Coltrane, loved these. And then lots of pop music that uses sus chords. Then we have our diminished triad 0-3-6, which we know pretty well. Then we have our major minor triad, which of course we discovered were both in the same set class, 0-3-7, or we go upside down, 0-3-7. And then finally the augmented triad, which we talked about, that only has 4 members. Okay, before we go any further, I want to show you how to determine the set class of one of these chords. This is what Dr. Hicks has asked you to do here. And it's not too hard. It looks a little hard, but let's start with, well, let's try number 9. That sounds like a Beatles song, number 9. Okay, let's go down here. I'm gonna take this one. Okay, maybe we can make this a little simpler for ourselves. Now the first step is we're going to count for all the pitch classes in the chord. And that means that we're going to write them all down and then try to put them in the most compact form that we can. Then we're going to count the order of the intervals from the bottom and then the top. Then we can use our fort chart to help us out. You can always have that. That's not cheating. I allow it and I recommend it. And on your test, you will be allowed to have this chart with you as long as there's nothing written on it. Now, the other thing that's very helpful is to write a little fake keyboard. I strongly recommend it, and here's how I would do it. I did this when I was in your situation. I'm not very good at this because I'm filming and writing at the same time, which I'm not very good at. Okay, so I make this keyboard. Okay, oh, that's not right. Let's put another one of these here. Okay, so that's like a keyboard. I can use that to count. You know what, I'm just going to write a treble clef because I'm going to rewrite these pitch classes. It doesn't matter what octave placement they're in, and this will help me. Okay, let's just write them in the order they appear. We'll start with E. The next one up is a G, A sharp, C sharp. Well, okay, I'm going to change these to B flat, and well, look, we've already got a B flat here, so it's a doubling, and then a C sharp or D flat. Why not do that? That makes it easier. So it turns out that I've got a doubling here, an A sharp and a B flat. So instead of having 5 notes, I have 4 notes. Boy, this one's really easy. It's E, G, B flat, D flat. It's a diminished 7th chord. We don't need to do much with this. And so that would be 0, up, 3 semitones. There's E, F, F sharp, G, 3 semitones. And then up 3 more, 1, 2, 3. Sorry. 1, 2, 3 to B flat, and then 3 more B flat, C, or B flat, B, C, D flat. That's 0, 3, 6, 9, which of course we know from our chart is right here, 428 or 0, 3, 6, 9. You can write it however you want, 428 or 0, 3, 6, 9. With the parentheses. I don't care. I mean, we should try a harder one actually. So let's try this guy right here. But I'm going to use that same keyboard diagram. But let's just sort of look at what's happening here. Now, one thing we can do is, well, again, this is bass clef. It's treble clef. Okay. Let's just start with B down here and go up. No, there's a C. Okay. There's a D flat. There's a B flat and an A. So, well then let's put this A here and this B flat here. Now, clearly, this is not the most compact version of this, because we've got this big gap. If we have big gaps, we know we have to shuffle the pitches around. So if we move these 3 up an octave, see right now we've got B, C, D, A, B flat, B, C, B, C, D. That's as wide as we could possibly get. That's 11. I can't even play it with one hand. So let's move these guys up an octave. Okay. And we'll go like this. So if we find a gap, that's probably where we should have the bottom of the chord, right? Because that'll give us the most compact results. So I'm going to write this B, C, D flat here. Okay, I'm pretty sure that's my normal order. Now the only thing that remains is to go, do I go 0, 1, 2, 3, 4 or 0, 1, 2, 3, 4? Well, they're both the same, so wah, wah. But what we would do is we would count it up and then count it down. Then we would look at our chart and, well, then we would determine which one is the most compact toward the 0. Starting with the second element of the set, and if that's the same on both of them, then the third element, etc., until we get the most compact towards 0 or the lowest sum. Now in this case, again, 0, 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, 5, which we could look up if we want. It's going to be 5, 1. 0, 1, 2, 3, 4. Yeah, that's it. Okay, so I hope that gives you an idea of how to proceed with this. And if not, give me a shout. You can email me, or we can set up a Zoom or phone call or whatever. Okay, now I'd like you to pause, and I'd like you to watch and listen to. I've just put one video, a link. This is Schoenberg's Opus 3 piano pieces, Opus 11. These are sort of landmarks in A-tone music, and they're quite nice, expressive, interesting. And the video, of course, has a streaming score, which I think is awesome. I think that's why the internet was created, for these streaming score videos. Please watch and listen to the whole thing. It's 13 minutes now, and then come back and watch the rest of this. Okay, I assume you've watched that video and listened to the whole of the 3 pieces. We're only going to look at the first, 11 bars. Oh, this is kind of interesting. 11 bars of Opus 11. And this is, of course, an important sort of landmark in the history of music. Even this 11 bars, it's analyzed a lot and studied a lot. It's very good at illustrating some basic concepts of 12-tone theory. I apologize for the sounds of my stool here. Anyway, let me play a little of it for you, just this passage. Not as well as Polini did, but we'll do our best. We'll just stop there. Now, let's look at this a little closer. If we were to analyze this formally, I think what we would decide is that it's in 3 parts. And when we talk about 3-part or ternary form, it almost always means A, B, A, or we have an A section, we have a B section, we come back to the A section, or a version of the A section, A prime it's sometimes called. So we would start here with our A, and then B, we have this passage that's a little bit different. So we have da 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 ba dum ba dum, and then here's the B section. Da 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 da. We have 3 statements of this very similar little motive, and then we have da 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 ba dum ba ba. Harkens back to this. We could even view this as this is an antecedent and this a consequent. In other words, a question and an answer. Question and then a kind of digression and then maybe an answer which has maybe been informed by this digression. Now the other thing we should keep in mind, I talked to you about Schoenberg and his place within the intellectual history of the German-speaking people or of Europe in general. I mentioned Hegel. We know about something called the Hegelian dialectic, which was very influential in German thinking, and I think somewhat incisive and interesting and true even, which is this idea that you have a thesis, something that's proposed by one person, an antithesis, a contradictory statement, and then a synthesis, the bringing together of the 2 initial statements, the first one and then the contradictory one, and then they come together. Now this is a procedure that's followed, of course, in academic discourse, but it also forms the basis of sonata form, where you have an exposition that has 2 ideas, and then they kind of are combined or duke it out in some way in the development section, and then in the recapitulation, they come together in the same key and sort of become a single unit. But in this case, we've got 2 motives and 2 different types of chord that I believe come together to form a sort of a unit, a single unit, and I'll show you how that works. So, and this is we're talking about the tricky thing of how do we analyze music using pitch class sets, which you may say, gosh, I don't even know what would that mean. Well, I'm going to show you how that works. And there are no right or wrong answers. You remember analyzing tonal music harmonically, there are right and wrong answers, well, to a certain extent. So we know that if we have that or this, that's a C major triad. If we're in the key of F major, that would be a 4 chord in root position. Well, in this kind of analysis, there's a lot more left up to the analyst to decide. So how do we do this? Well, first we would want to chunk notes according to ways in which they sound like they belong together. And this is certainly going to be where we have a motive that seems to fit together or a chord. And so we might look at those motives or chords. We might, write some of those down, analyze them, figure out what set class they belong to. Then once we get a list of set classes that seem to be important, we could look for those set classes, okay? But only if they're significant. And for the most part, if we want to analyze more than one pitch class as belonging to a set class, we would want them to either be simultaneous or adjacent, next to each other or on top of each other. If we took any, if I took a pitch class here and one there and one there and one there, I could come up with any set class I wanted. So that's not significant. But if they belong together in some way, then I think it is interesting and significant. So first off, we can say, I think we have a trichord that belongs together here. So let's circle this. Let's figure out what it is. G, G sharp, B. Okay, I think it's already in normal order and it's already prime form. And if I look on the chart, I would figure out that it is a 014, which of course is our atonal trichord. Maybe I'll use my my blue pen. Might show up better. Okay, so I've got a 014. And we're not surprised by that because, of course, Schoenberg loved this harmony. But we've got, and then we've got this. Already we've got a motive. We've got a descending third followed by a descending step. The rhythm's a little bit different, and this one's repeated, but it's very similar. Okay, in this case, and Schoenberg has notated it in a way that suggests that this is definitely the melody. Now you can see already by doing this, this would help us to interpret this piece, to play it better in a more sensitive and expressive way. Now you can see also, he's told us that these are chords, these are accompanying figures. So let's circle these. No, yeah, and let's figure out what set class this little thing is. It's an E, an F, and an A. 0, 1, 2, 3, 4, 5, 0, 1, 5. Again, if we were to look on our chart, we would find that that is most assuredly the normal order in the prime form. Okay, now let's look at this one. This is a little trickier. We've got a G flat. Again, I'm going to move the octave placement. G flat, F, B, and I could move the B down here, but this is going to give me a better thing. Now, what's interesting about this 0, 1, 6. This is actually an inversionally symmetrical trichord, because if I move this F down there and I count it from top to bottom, I also get, no, that's not true. Forget about it. Anyway, this is 0, 1, 6, F, G flat, B. And then, lo and behold, this is a B flat, D flat, A. So A, B flat, D flat, 0, 1, 4, which we already saw over here, which is kind of interesting. Here's another instance of a kind of a question and an answer. It's you know, the upper voice, if we wanted to call it, or the soprano, is answered in the alto, tenor, and bass at the end of this figure. Okay, by a transposition of that chord. Again, forgive the tuning of this piano, which was moved recently. Anyway, okay, so that's that tells me that I've got a collection of, you know, 3 trichords that are quite similar, 014, 015, 016, and it's like 2 trichords that are right next to each other on our chart. Okay, now let's look at what happens here. And again, what I'm finding is, the other thing that this opening suggests to me is that we're dealing with trichords. That's probably what we should look for. So that's what I'm going to do. Okay, first thing is these seem to belong together. And then this belongs together. And this seems to be like an answer to that, an imitation or an answer. And what's interesting is if we take the B flat, C, E, that's our incomplete dominant 7th chord, 0, 2, 6, 0, 2, 6. And then look at this one, G sharp, D, F sharp. Well, let's move the G sharp up an octave. Okay, now let's count it from the top, 0, 2, 6. Okay, so remember, once we get the normal order, we try counting it from bottom to top. Oh, sorry. 0, 2, 6, 0, 2, 6. We try counting it from bottom to top and top to bottom and see which one is more sort of normal, and then that gives us our solution. Okay, what ends up happening? Okay, we've got the 0, 2, 6. And then let's look at, we've got a few other things that we could look at. Now again, this is a point where we start looking for these trichords. Well, here's one. G, B flat, B. G, B flat, B. If I count it from top to bottom, 0, 1, 4. We've got a 0, 1, 4. Okay. And let's look at this. F sharp, A sharp. It's a little harder to see. F sharp, A sharp. That's the exact same chord, but down a semitone. 0, 1, 4. And same thing, we've got these diagonal, you know, imitation from the right hand to the left hand. Again, this illustrates this idea of the unity of musical space. We're looking at shapes that exist both in melody and harmony and in hybrids of melody and harmony. It's not so much melody accompanied by harmony, it's melody and harmony are sort of the same. Okay, so 0, 1, 4, 0, 1, 4, 0, 2, 6, 0, 2, 6, and then we've got this, well, let me show you one more thing, which is this here, which so then here's a 0, 1, 5, which we had earlier, the incomplete major 7th chord. And actually, if we were to do this, which is maybe cheating a little bit, there's another 0, 1, 5. It's upside down, C, B, G. Okay, and then we have, these passages are exactly the same. We just have that he's playing with the rhythmic placement of these notes. So we have, that's the first one. He's delaying the left hand. And then this one's a little different. He's got some other notes. And this is to be expected. Whenever we have musical phrases in threes, like in a sequence or a repetition, or in a joke, or in a fairy tale, whenever you have threes, the third thing is always altered a little bit. And so it's kind of surprising because we're expecting a repetition and then it takes us somewhere else. That's what happens in this third one. Now, what do we have in this third one? Well, first of all, we have that D flat introduced, which we haven't seen before in this section. There's another 0, 1, 4. And then we have C, B flat, G. Let's see, what's that? That's a 0, 2, 5. We haven't really seen that. So, you know, there's some outliers here. But, you know, of course, we have the other ones that we saw earlier. But here's our 0, 1, 5, of course. Okay, so there's some interesting stuff happening here. First of all, the 0, 2, 6 is introduced. And in the context of this ever widening, you know, gradually widening trichord, 0, 1, 4, 0, 1, 5, 0, 1, 6, then what's the next step? If we go 0, 1, 4, 0, 1, 5, 0, 1, 6, well, what if we, instead of going to there, we take the second one and raise it? That's what we got. So we've got this very gradually rising thing, and we see these other friends also, the 0, 1, 4 and the 0, 1, 5. Well, when we get back to the motive, descending third, descending second, well, we've had the descending minor third and the descending minor second. Then we have the descending major third and the descending minor second. We only have one more permutation left, which is descending major third, descending major second, which gives us, you'll never guess it, the 0, 2, 6, which is quite exciting. So he's taken this motive, he's hinted at possibilities here, here, and then he's given us this new version enlightened by this B section. And then we have this one, 0, 2, 4, which we haven't seen at all, but suggested maybe a little bit by the 0, 2, 6, this kind of whole tony concept. And then this little thing here, this little hiccup, which of course you recognize as our 0, 1, 4, telling us that it's never very far behind. And this one, interestingly, includes that G sharp, but it's a different format from that one. And this is the best part of all. What happens here on the last bar? Now, I'm going to ignore this A, because it was part of this whole thing. I could extend this over. But let's look at what's happening here. Well, obviously, that's our, if we put the F down there, that's our 0, 2, 6 that we saw a lot of, you know, that was introduced, and that ultimately became the new form of that motive. So there's our 0, 2, 6, but if we go over here, we take this B flat and, you know, make a new chord. The G and the B and the B flat, that gives us a 0, 1, 4. So this, and then that gives us the exact chord that I told you about, which is, includes that 0, 1, 6. Okay, there's a 0, 1, 6 in there. If we take the B flat, oh, B flat, B, and an F, and we count it downwards, we get the 0, 1, 6. So that's part of this too. I need another color to show you that. F, it would be these three minus the G. So that's the 0, 1, 6. If we put them all together, it forms, okay, let's look at this, and let's get a piece of stock paper so we can figure this out a little bit. We've got G, B, B flat, F, G, B flat, B. Let's put the F down here. I think that's pretty good there. Let's count it from, well look, this is a bigger interval, so let's count it from the top. 0, 0, 1, 4, 6. 0, 1, 4, 6. Now let's have a look at the 0, 1, 4, 6 on our fort chart, shall we? We want to make sure it's here so that we know that it's the prime form. Let's see if we can find it. There it is, the 0, 1, 4, 6. Now, this is kind of an interesting chord. Look at it closely. What do you notice about it? Well, look at the vector. This is the only no, it's not the only instance, but this is an unusual vector. It has one of every interval class. There's one other tetrachord that has that, and that's down here. Now, what do you notice that these two chords have in common? It's the Z. These are Z-related tetrachords. The Z relation, all that means is that they share the same vector. And those are the only two Z-related tetrachords. If we go to pentachords, there are more. If we go to hexachords, there are more. And so, but this one's particularly interesting because they contain one of each interval, which is kind of exciting. It means that the chord is very rich. And that means the composers who have been aware of this theory have focused a lot on these two chords, and especially this one, the 0, 1, 4, 6, the 4Z15. That one, and this brings up the subject of, where this theory fits in, because the Second Viennese School music that we've looked at was written long before 1950 whatever, when Fort wrote his book about atonal music. It was written without a knowledge of pitch class set theory, without this chart, etc. However, Schoenberg, Berg, and Webern were using techniques that are definitely suggested by this, or that were inspired this method. Then, starting in the 1950s, we get composers who are interested, who learn about and learn this theory and read about this theory, who decide, well, this is a good method for composing music, and they actually consciously use pitch class sets. Now, certainly my generation of composer, we were taught this, and we were taught to use this to compose, and earlier generations. So two composers who were particularly interested in using pitch class set theory to compose were Elliott Carter and George Crumb. Elliott Carter, who died a couple of years ago, and George Crumb still alive. Both of these composers love this, particularly this all-interval tetrachord. And you can see how it contains all of these intervals. Here, I'll show you on the piano. So if I go 0, 1, 4, 6, okay, interval class 1 right there. Interval class 2 right there. Interval class 3, interval class 4, interval class 5, and interval class 6. And now you could have it like this, or 0, 1, 4, 6 has a different sound. And again, lots of cool chords can be made with this, especially the sharp 9 chord and the 13th chord, which we know from lots of classical music, especially Romantic period. Grieg loved it. Those are both 0146s. And then this one, 0137, which again we recognize as the 4Z29, 0137. It's kind of a minor triad plus a flat 2 or flat 9, or 0137, a little more familiar, major triad with a sharp 4th. So we've heard lots of those. So those are the all-interval tetrachords. Now, back to the Schoenberg. You may be saying, well, Dr. Asplund, I don't know, how did you come up with that? And, you know, who cares, whatever. Anyway, well, as I said before, the way to do this type of analysis is to find set classes that stick out in the texture of the music and see if you can find set classes that occur more than once, that seem to happen more than once, or ones that seem to relate to each other. Once you've found those, then you can find the hidden, somewhat more hidden instances of those set classes. And again, I tend to stick with trichords and tetrachords. Other music theorists will use bigger chords. For me, I kind of don't hear them if they're bigger than that. But these I can definitely hear, you know, or this, or I can definitely hear this. I can definitely hear that, how that fits in with this, how those fit together. So trichords and tetrachords. Now, I'm not going to necessarily ask you to analyze a piece from scratch. But I may get you started and say, well, can you find another instance of this chord? Or can you find, you know, for instance, inversionally symmetrical chords and things like that. But we'll get more into that. But you know, of course, we select a passage which works particularly well. A lot of pieces that we would analyze using pitch class sets do not, the analyses are a little more complex, or they're not quite as straightforward. This one is fairly straightforward and you can kind of hear it. So that's the advantage of it. Anyway, we'll talk to you soon. Goodbye.